Okay, so here's the question. In 2004, a school population was 827. By 2008, the population had grown to be 1191. So it's grown quite a bit. So here they're going to ask us a series of questions about this. How much did the population grow between the year 2004 and 2008? Well, to figure that out, we're just going to have to subtract these two population numbers, 1191 minus 827. So I'll use my calculator here. 91 minus 827. Was it 364? 364. Okay. How long, next question, how long did it take the population to grow? Well, that was from 2004 to 2008. That was 4 years, just 2008 minus 2004, 4 years. And that was 364. Okay. And then third question, what is the average population growth per year? So the average population growth per year, what are they talking about? Well, they grew by 364 students over 4 years. So if you divide that, I'll divide that on my calculator, I'm getting 91 students per year is the average. So that makes sense. That's the average population growth, 91. And the units here are going to be students per year. Students per year. Does that make sense, what we're talking about there? Right? The population at the school, the number of students, grew by 364 students over a period of 4 years, from 2004 to 2008. So over a period of 4 years, the number of students went up 364. So if you divide that, that's on average 91 students every year. That doesn't mean they got exactly 91 students every year. They might have got 100 students a couple of years and then 80 a couple of years, but it averaged out to like they were getting 91 students every year, students per year, average population growth. Notice that's basically a slope. Here's the y2 minus y1. Here's the x2 minus x1 on the bottom. See that? It's basically a slope calculation, isn't it? See that? Okay. What was the population in the year 2000? Well, I guess they're assuming, I guess, that it just keeps going up, or did keep going up by the same amount. So, okay. So to find the school population back in the year 2000, that's kind of tricky. And then number 5, they want us to find an equation for the population. And then in number 6, use your equation to predict the population in 2011. So I'm just going to dive in and find the equation right now. Let's just do that. So, all right. So remember, we learned before how to find linear equations. So I'm going to kind of jump down and do number 5, and then I'll use number 5 to help us with 4 and 6. All right. So let's do that. So what do we have? So here's the information we have so far. In the year 2004, population was, what was it? 827. So, and then in the year 2008, the population was 1191. Okay, what are we going to do with that? Well, that basically tells us points. That basically tells us that this is 4, 827. And this is 8, 1191. Now, why am I using 4 and 8 instead of 2004 and 2008? Well, because see how they're saying T years after 2000? So this is years after 2000. That's my X or my T. And then my Y, so my X is years after 2000 and my Y is population. Population. Is that making sense? So I'm just, remember how we did this? We did this before. I'll go back to the notes. Let me jump you back to the notes here. Where is it? Notes, exam 1 note, no, exam 2 notes. There they are. So the exam 2 notes, there it is, finding a linear equation. So from the exam 2 notes, I gave you some notes up here about finding a linear equation. There it is. So finding linear equation. So you can look through this, but basically you got to identify 2 xy points, find the slope. Now use the different version of the slope formula. So that's what I'm basically doing. So step 1, find 2 points. I got my 2 points. And how do I know what to use? Well, you know, they said T years after 2000. So I'm using this as years after 2000. Step 2, find the slope. Remember slope, y2 minus y1 over x2 minus x1. So let's do that. So so this is my x1, y1, x2, y2. So let's grab that stuff. So y2 is 1191. It's my y2, and then my x2, my y1. Sorry, I'm getting confusing here. 827 over x2, which is 8 minus x1, which is 4. It's x2, x1. So I'm finding the slope. Let's do it. So the slope equals, you subtract those on the top, you do that. 91 minus 827, 364 over 4. Divide that, you get 91. Yeah, that's what we said earlier. Remember, we said 91, that's like a slope. That's exactly right. Slope, notice slope is average population growth. That's what they're wanting us to see in this problem, is how these formula stuff we're doing has real life connections. What 91 is, what the slope is the average population growth, right? Because it's population per year. So it's people per year, students in particular per year. Students per year. So 91 students per year on average is how much the population is growing by, 91 students a year. So that's the slope. So then step 3 says use the slope formula again, but this time you use it with the plane y and the plane x in the front. So this seems to be the step that's confusing most people. Are you guys okay with that? So I think where people are getting confused is they feel like once they got a slope, they're done, but you're not done. You've got to use the slope formula twice. Whenever you're trying to find an equation. Everybody with me on this? Right now, I am finding an equation. So let me write a note on that. To find an equation, we must use the slope formula a second time. Is that making sense? I think that's confusing people. So when you're trying to find an equation, you must use the slope formula a second time, and this time with the plane y and x in the front. See how it's a new version? It's just about like this one. See the difference? This had y2 and x2 in the front. This says plane y and plane x. Still have y1, x1 in the back. No difference. Slope in the front. No difference. The only difference is we used to have y2, x2 in the front. Now we have plane y, plane x. So you have to use that new version of the slope formula. And why do we do plane y, plane x? What's the meaning of that? Well, that means they're going to stay there. We're not going to put a number in for them. We're not going to plug a number into plane y or plane x. They remain plane y, plane x. We plug numbers into the x1, y1 and the slope, but not to the plane y, plane x. That making sense? So we got the slope. We got the slope right here. So that goes there. So 91 equals. And then we're going to go y minus x minus. And then what are we going to do for the x1, y1? We'll just go grab them. We got them back here. Here's x1. Here's y1. x1 is 4. Put that on the bottom. y1 is 827. There we go. And now you know the drill, I hope. Do you know the drill? Step 4. Cross multiply. Put this over 1. Diagonal, diagonal. And what do we get? 91 times x minus 4 is 1 times y minus 827. Distribute. 91x minus, what's that? 364 equals, and distribute. Y minus 829. We're almost there. Add the 829 over to get y alone. Boom, boom. Y is 91x plus, and just subtract those on your calculator. So I'm about to do 829 minus 364. I'm getting 465. So there it is. There's a formula. Now, what's this y and x stuff? Well, remember what y is? Y, here, y is on the top. What's y? Students. Y is students, and x is years, right? Y is, this is x is years after 2000, and y is the population. So y is the population. And so really we could rewrite this formula. Let's put it over here, put the y on the left. We could rewrite this formula as P for population is 91T plus 465. That's the same formula. I just like doing y and x because we're used to y and x, but that's the same formula, isn't it? I'm just using t instead of x and p instead of y. P stands for population. T stands for years. T years after 2000. That's exactly what I did with y. Y has been the population all along. X has been the years after 2000. Right? We see it right back here, right? X was 4 and 8. That was for 2004, 2008. That was years after 2000. And Y was the population. All right, so we got our formula. That's actually the answer to number 5, 91T plus 465. That's 91T.
Mr. Heron.
65. Question?
For your points, you know how you put just, what was it, 4 and 8? I mean, right. Technically, you could put 2004 and 2008 and still get the same answer, right?
Well, not on number 5 because of how they specified number 5. They say we want T to be years after 2000. Does that make sense? So in other words, so imagine that we're talking, and I say, because that's what this is. This is just a form of communication. If I say to you, hey, let's talk about what year the Tom Brady's going to win the Super Bowl again. And rather than say, I think it's next year, 2022. Rather than say that, I would like us just to say it in terms of years after 2000. So you say, oh, okay, 22. And we understand you mean the year 2022. But we've agreed when we speak, we're going to be speaking in years after 2000. Well, that's what they're saying we have to do here.
So if we did write 2008 or 2004, we would get that wrong?
You would get that wrong.
Gotcha. Okay.
Well, actually, when it's subtracted,
it's the same thing.
Out. Is that right?
Yeah, if you plug them both in, they come out to the same. That's why I was just curious.
That's right. That's right. Why does that work out? Is that always going to work out?
I think so.
Oh no, but it will not work out right here. You get the same slope, But when you do the second slope formula, you see you would have plugged in 2004 right there, not 4. And that would have messed it all up. Does that make sense? The slope would have come out the same, yes. But the equation would not be the same in the end if you plugged in 2004 instead of just 4.
And when would you, okay, so then when would you put 2004? If it just
We're not going to at all.
Huh?
So not at all. So right here, so again, it's all about this. They're saying to us, here's how we want to communicate. We don't want the 2000s. When we say T, we mean years after 2000. So therefore, when I first originally wrote 2004, right away I changed that to 4. The 2008, right away I changed that to 8. And from then on, I just used 4 and 8.
Because didn't we in the previous section, didn't we actually write 2004 and 2008?
You could. They could have made this problem that way too. Does that make sense, Tim? Your questions are good. I want to make sure, because this isn't just a weird thing on this problem. They do this all the time in math and science, chemistry, physics, astronomy, biology, other math classes, all the time. This is, especially in sciences, this is very, very common. So let me help you. You really want to get the hang of this. They do this all the time. They'll specify how they want a certain variable to go. Okay. So they didn't have to say this, and sometimes they won't. And so what you need to do is get comfortable whether they say it or don't say it, and know how to go both ways.
Could you give an example?
What they do in the math science world. So if they had not said this phrase, in fact, if they had just said T in the year T, you know, like whatever the year, then I would have had to straight out use the 2004 and the 2008, because they're saying we want the actual year, please, the actual year. Then I would have had to follow their communication standards. But if they say no, T is going to be years after 2000, please, well then to say the year 2004 is just to say T is 4.
Okay, because I think in the last section we were actually writing the whole year.
I believe number 2 is like that, where you have to write the whole year, because that's the year since 1990. So I think for question number 2, we're gonna have to do that.
Yeah, that's because I'm on the.
I'm getting a little confused. So Carlos, you're talking about question number 2 on this homework?
Yes, on this one.
Okay, that's great, and you may be right, but Tim's referring to the last section, I think, right?
Oh, okay. Right.
Well, I meant because like the last section we had a problem where we used that formula, and now.
And use the whole year, you mean?
Yeah, now
that very well could be. Honestly, I don't exactly remember. I teach too many classes and I get confused between it. You could totally be right. That may be the case.
Okay.
Does that make sense?
Just look for 2 years after. Just look for that.
Yeah, so they can change it up. So we have to just read what they say and follow what they say. Because sometimes it goes the other way. Sometimes we use the entire year. And sometimes they say this kind of phrase. So good question. Really good question. I know that stumbles a lot of people. Is that making sense? Really, it's not a math thing as much as it's just a communication thing.
Okay.
They're just literally saying, here's how we want T to work. We want T now to signify years after 2000. We don't want the whole 2000 thing. We just want it to be years after 2000. Good question. So when they say that, then we have to follow their lead and do what they say. And if they don't say that, then we have to not do that. So we have to pay attention to what they say. Good question. So we get down here. And so I've got the formula 91T plus 465. Now I'm going to kind of backtrack to number 4 and answer that. Because it's easier to get the formula first and then answer that. So using that formula, what was the population in the year 2000? So we've got this P population is 91T plus 465. And remember what T is? Again, it says it right here. I don't need to go anywhere. It says it right there. T is years after 2000. So therefore, how can I use that formula now from number 5 to back up to number 4 and figure out the population in the year 2000? What would I do with this formula to figure out the population in the year 2000? If it's the year 2000, what's T?
0, right?
Beautiful. 0. Is everybody seeing that? Because that's 0 years after 2000. If it is the year 2000, then that's no years after 2000, right? So that means plug in 0 there. So what are you going to get? 91 times 0 plus 465. And so what's that answer? Just 465, huh? Does that make sense? And then in question number 6, it says the school year 2011. So what am I going to plug in for T if it's the year 2011? 11, because that's 11 years after 2000. You're getting it? Right. So then I got to plug into the same formula. This time, plugging in 11 for T. So what do we get? 91 times 11 plus 465. And then just hit the buttons on your calculator. That's what I'm going to do. I'm getting 1466. So if the growth continues in the same linear fashion, they keep going up by 91 students per year, which has been their average, then by the year 2011, they'll be up to 1466 students, because that's 11 years after 2000. So you see how this formula works. This formula is allowing us to find the population at any time T, which is in years after 2000. We just plug in to that formula. And that was a lot of questions. 6 questions. Do we answer all the questions? I think we did. Yeah, right, just 6. Just 6. And there they are.